Venus is almost the same size as Earth. But while Earth became a paradise, Venus turned into a nightmare. Surface temperatures reach 464 degrees Celsius, even hotter than Mercury. The atmospheric pressure is 90 times stronger than on Earth, enough to crush almost anything. The sky is covered in clouds of sulfuric acid, and when it rains acid. Space probes have tried to land there, but the longest mission survived only a few hours. And the most unsettling part is this: billions of years ago, Venus may have once looked a lot like Earth. Venus is the second planet from the Sun, orbiting at an average distance of about 108 million kilometers. Its orbit is almost perfectly circular, with very little eccentricity. When Venus moves to its closest position relative to Earth, the distance between the two planets drops to about 41 million kilometers. This makes Venus the closest planetary neighbor to Earth after the Moon. But there is something interesting about this moment. When Venus is closest to Earth, it is actually not at its brightest in the sky. That's because Venus sits between Earth and the Sun, and from our perspective we mostly see the dark side of the planet. Venus has one extremely strange characteristic: it spins backward. Most planets in the solar system rotate in the same direction, but Venus rotates in the opposite direction. Not only that, its rotation is incredibly slow. Venus takes about 243 Earth days to complete one rotation around its axis. Meanwhile, it only takes about 224 Earth days to orbit the Sun. This means a single day on Venus is actually longer than an entire year. Scientists still aren't completely sure why this happens. One idea is that billions of years ago, a massive celestial collision may have knocked Venus into its unusual backward rotation. Humans began exploring Venus very early. During the Cold War, both the United States and the Soviet Union launched numerous probes toward this mysterious planet. But Venus turned out to be an extremely hostile place. The intense heat, crushing pressure, and thick atmosphere caused most of the missions to fail. Between 1961 and 1967, 15 missions were launched, but only a few were considered successful. Still, the Soviet Union continued trying. In 1970, the Venera 7 probe became the first spacecraft in history to successfully land on the surface of another planet and transmit data back to Earth. Although it survived for only about 23 minutes before being destroyed by the extreme conditions. It opened the door to our first real understanding of this hellish world. The atmosphere of Venus begins about 250 kilometers above the planet's surface. At this altitude, the air is still relatively thin and temperatures remain fairly low. But as you descend, the atmosphere becomes dramatically denser. In fact, nearly 99% of Venus's atmospheric mass lies below 60 kilometers. The atmosphere is dominated by carbon dioxide, which is the main reason behind the planet's powerful greenhouse effect. As we continue descending, we enter the thick cloud layer that defines Venus. The pale yellow clouds covering the planet are actually made of sulfuric acid. These clouds stretch from about 60 kilometers down to roughly 40 kilometers above the surface. Ultraviolet radiation from the sun breaks apart molecules in the atmosphere and triggers chemical reactions that form these acidic clouds. Venus even has rain, but it rains sulfuric acid. However, the temperature is so extreme that the droplets evaporate long before they reach the surface. Inside this cloud layer, winds can reach nearly 100 meters per second, allowing the atmosphere to circle the entire planet in just a few days. Beneath the sulfuric acid clouds, the atmosphere of Venus becomes extremely dense. The dominant gas is carbon dioxide, making up more than 96% of the atmosphere. This massive layer of CO2 acts like a giant thermal blanket, trapping almost all the heat from the sun. As sunlight enters the atmosphere, the heat becomes trapped and cannot escape back into space. This runaway greenhouse effect causes temperatures to rise dramatically. As a result, the surface of Venus reaches around 464 degrees Celsius. Even hotter than Mercury, despite Mercury being closer to the Sun. At this temperature, metals such as lead can actually melt. Thick clouds completely hide Venus. From space, we can barely see the surface of this planet. Visible light cannot penetrate the massive atmosphere surrounding it. For decades, the surface of Venus remained a mystery. The only images ever captured came from the Soviet Venera landers. When they touched down, The probes survived only for a short time. Temperatures above 460 degrees Celsius and crushing pressure quickly destroyed the spacecraft. But before they failed, they sent back the first images of Venus, a yellow-orange world covered with basalt rocks and fields of frozen lava. The thick clouds of Venus make it impossible to observe the planet's surface with ordinary telescopes. Visible light, infrared, and ultraviolet radiation cannot penetrate the massive atmosphere surrounding it, so scientists turned to a different method: radar. In 1990, NASA launched the Magellan spacecraft to Venus. Instead of taking images with light, Magellan used radar waves to scan the planet's surface. Over several years in orbit, the spacecraft mapped nearly the entire surface of Venus. Thanks to the data collected by Magellan, humanity was finally able to see the true landscape of this mysterious planet. When scientists began analyzing the radar maps of Venus, they discovered something surprising. The surface of the planet contains very few impact craters. In total, Venus has fewer than 1,000 craters across its entire surface, and they are distributed fairly evenly. This suggests that the surface of Venus is geologically young. If the surface were extremely ancient, we would expect to see countless impact craters of all sizes. However, many small craters do not exist on Venus, because smaller meteoroids usually burn up while passing through the planet's extremely dense atmosphere. Across the surface of Venus, scientists discovered enormous circular structures known as coronae. Some of these formations stretch hundreds of kilometers across, larger than many cities on Earth. These strange rings were not created by meteor impacts. Instead, they formed deep within the planet itself. When hot material rises from the mantle, it pushes the crust upward into a massive dome. But as the heat fades, the crust collapses and fractures outward. Over time, this process leaves behind the giant circular patterns we now see across the surface of Venus. Unlike Earth, Venus appears to have no plate tectonics. The planet's crust behaves more like a single solid shell rather than being broken into moving plates. This means heat from the interior cannot escape easily. Over time, that energy builds up beneath the crust. When hot material rises from the mantle, it pushes the surface upward and forms the massive circular structures scientists call coronae. On Earth, heat from the planet's interior can escape gradually through plate tectonics. But on Venus, that process barely exists. The crust behaves more like a single massive shell. Over time, heat continues to build up beneath the surface. For hundreds of millions of years, the pressure keeps increasing. Eventually, the crust can no longer hold it back. Massive amounts of lava erupt from below and spread across the planet's surface. Scientists call this a global resurfacing event. It may have erased almost the entire ancient surface of Venus. Some studies suggest that Venus may once have been very different from the world we see today. Billions of years ago, the planet may have had liquid water on its surface, possibly even shallow oceans. But as the sun slowly grew brighter, that water began to evaporate. Water vapor is a powerful greenhouse gas, trapping more heat in the atmosphere. Eventually, this led to a runaway greenhouse effect that transformed Venus into the hellish world we see today. In 2020, scientists announced a surprising discovery. In the atmosphere of Venus, they detected traces of a gas called phosphine. On Earth, phosphine is often associated with microbial life. This led some researchers to ask a bold question: could microscopic life exist within the clouds of Venus? However, the discovery remains highly debated, and more observations are needed to confirm it. To answer these mysteries, scientists are preparing to return to Venus. In the coming years, several new missions will be launched to explore this planet. Advanced spacecraft will dive through its thick atmosphere, study the chemistry of the clouds, and map the surface in far greater detail than ever before. Scientists hope that these new missions will finally reveal the true history of Venus. Why a planet so similar to Earth turned into a hellish world, and whether something unexpected might exist within its dense clouds. Venus is right next to Earth, yet we still know surprisingly little about it. And perhaps the most mysterious planet in our solar system is the one closest to us.